Hi, today we'll be doing an Arraylist implementation in Java. So we'll be continuing our data structures video series. We'll be doing in an Arraylist, and it's an abstract class. So we're going to be having an unordered and ordered version of both. And then after this, we'll be doing a linked list implementation of our list, ADT. So we'll be using our list ADT, unordered list ADT, and ordered list ADT in whatever order. And then just see the previous videos if you want to see how those interfaces were created and what they are and all that. If not, you can just pause the video and copy them. But I recommend to just look back on the channel when I upload these videos and just to go through them so that you know what's happening and you get a proper explanation. So I've already created an Arraylist class, So we're going to be using generics again. So I'm using IntelliJ, so public abstract class, Arraylist. So an Arraylist is a list that is implemented using an array. And we'll say it implements list ADT of generic type T and iterable of type T. We'll be going over the iterable stuff later, just implement it for now. So we'll just have some doc here and we'll say Arraylist represents an array implementation of a list. The front of the list is kept at array index 0. The front of the list is kept at array index 0, or the head of the list. This class will be extended to create a specific kind of list, either unordered or ordered. It's just the way this book does it. Java Foundations, because I believe it's also indexed, but they just put it under just a general list ADT. They didn't say it was an index list, because of course there is an index. So I guess it's just kind of a bias, their own bias. So here we'll do the constructor. Public. Actually no constructor yet. We'll do some instance data, so private final static int default capacity. So this is going to be similar to the stack, array stack. Actually that's too much, we'll just say 5 for testing purposes. Well, then we'll create another private final static int not found equals to -1. We'll create a protected int rear and a protected t-array list. And a protected int mod count for the iterator. So here's a constructor. Oops. We'll say it creates an empty list using the default capacity. Say public array list. We'll call the this keyword. We'll use the other constructor to set it up, but we haven't written it. I think there's an error here, so I'm going to change it. So we'll put the other one above it. Put it above it, so creates an empty list using the default capacity. And then it's going to be an overloaded constructor, so here we'll put another constructor. We'll say creates an empty list using the specified capacity at param initial capacity. The integer value of the size of the array list. Here we'll say public array list, then int initial capacity. Could have just called it size. Here we'll just set rear equals to 0. And you can't instantiate a T array, so we have to cast it. We can instantiate an object of type T. So here we'll say list equals to casted T array to new object. Just kind of have to memorize it. Then here we'll say initial capacity. And we'll set mod count to 0. That's just for the iterator. So we'll discuss that later. Don't worry about it, I don't even think we're going to use it. We may use it in the next chapter in iterators. Mod count, you just have to keep them in sync, so when you edit the list or something, you have to, when you make an edit, you have to update the counter. So we'll go over that later. So here, we have our two constructors, one's overloaded. It uses the default capacity of 5. Then we'll do the expand capacity. So this is a long code, so there's a lot of stuff here. So it creates a new array to store the contents of this list with twice the capacity of the old one. Called by descendant classes. That add elements to the list. So protected void expand capacity. We'll use the array method. So we'll say list equals arrays. List equals to arrays dot copy of. That method I might have discussed earlier. Passes in list and list.length times 2 for the size. So it's just going to copy the array list, the array space list, so the array named list, and it's going to take the size list.length, so our current size, if it's 5, then it's going to be 10. We're going to have to import this. So we'll just hit Alt Shift and Enter. Then we'll just put a semicolon here. That's it. That's the easier way to do it. But you may actually have to create a secondary array if you debug this and you can't find your elements, because it might get lost. Because technically it's going to create another memory location for this new array. So I noticed when I was doing data structures, I tried to expand the capacity and found that my elements are being lost and it was just printing the old one. So you might have to instantiate a new array here. Like something like this, like T array equals new like a new array instantiation like this. T array list, and then list points to T array new object. And then you can call it like list2, and then you can say like list2 points to that array. So then you'll have a special memory location that the elements won't get lost. And here you'll say, for remove last, we'll say removes and returns the last element in this list. We'll say at return the last element in the list. We'll say at throws empty collection exception, so we're going to use that exception again. Empty collection exception. Returns type T. Public T remove last throws empty collection exception. If is empty, which we don't have. Throw new empty collection exception and then write array list here as a string. So we don't have is empty, but we will. Which one is it using? So it's getting it from the interface, but we actually haven't defined it yet, but we will. You can use brackets here if you want. I'd prefer to. And we'll say T result. We'll create a variable of type T named result. So when we remove last, we probably should have did the add once first, but this is a little bit different because there's no add methods in the general array list. We have to specifically create the unordered list and the ordered list because they add it in different ways. Like the ordered list has an order to it, and unordered list you choose the order. So this one is just, it does the remove methods first. So you have like remove last, remove first, remove. Then we have first, last. Those are easy. Contains and find is empty toString, and then we have iterators to do as well. So we'll just do it this way. We'll do the remove methods first. So we'll say rear counter, so every array list has a rear. Shouldn't we have a front as well? We just have a rear. Perhaps we will add a front later to our unordered and ordered. I feel like it would be good to have a head, or a front anyways. We can always add it later. So we'll just go with this for now. So rear will decrement by 1, and then we'll say result points to list of rear. because rear will probably be the next index to add an element, so at this point it was pointing to the next element. So now it's probably pointing to the element, the last element in the list. This was just the next available empty space. So now it's saying result points to list of rear. Here we'll just set list of rear to null now. Then we'll do mod count ++. That's for the iterator. And then we'll return result. Again, you don't have to worry about that. Just remember to, when you edit something, you shift an index, you remove something, you add something, you'll have to update the mod count. So remember, we're going to have to be shifting elements with this. So then here we'll say removes and returns the first element in the list. So at return the first element in the list. Add throws empty collection exception again if the element is not in the list. Returns type T. We'll call this again. So now, from now on, stuff that we've done before in the previous video series that we do quite often, I'm just going to kind of write it instead of explain it every time. So here we'll instantiate a T result variable of type T. Points to list of 0, index 0. We'll decrement rear. Then we'll shift the elements. Whoops. So we'll say for int scan equals to 0. Scan is less than rear. Scan ++. List of scan points to list of scan +1. Then here we'll say list of rear points to null. Mod count ++. And return result. So we'll go through this all through the debugger again, but here we just set the result to list of list of 0, so T result points to list of 0. Then we shift the elements. So in scan is equal to 0, scan is less than rear. Scan ++ list of scan points to list of scan +1, so they all get shifted up by 1. Actually no, sorry, so each element basically comes back a shift. Because list, so the current list of, so the list array index of 0 points to list of array index of 0 + 1 basically. So Yeah, so it's going to drop an element and then shift them all left. Then it sets the list of rear to null. I feel like there should be a front here somewhere. Well, it would be at least easier if we had one. But perhaps this implementation doesn't use it. So it's okay, we'll just go through it in the debugger later if we have any problems. This is just the way the book did it. So we can always fix it later. This textbook is notorious for having mistakes though, but it should be okay. Because I've already gone through all these. So it should be fine. I guess rear is kind of like top. But that's okay. So we'll just do the next one now. This is going to be like a 2-part video, and then I'll probably compile them, and then the link list is going to be another 2-part video. So most of the methods are in this general array list. I think unordered list has 3 methods and ordered list has 1. So they're pretty small. So we'll do the remove method here. So we'll say removes and returns the specified element. I'll also still use these lists sometimes, so they usually work to store stuff. And like when we do trees, we'll be using these. Trees will be in the next chapter after iterators, which iterators is just a short chapter. And there's going to be tons of code in trees, binary trees and stuff, so we'll be doing those. At param element, the element to be removed and returned from the list. At return the removed element. At throws element not found exception. I think we might have to create that one. If the element is not in the list. So here it returns type T again. It takes parameter T element. It's a public T remove. Then we'll say T result index points to find element. We haven't created find yet. We will in a sec. I should have did that one first. That's okay. Then we'll just say if index is not found. Not found, we have a constant for that. Is -1. Because find probably returns a -1 if it's not found. Just like index up. So we'll say if index is not found, throw new element not found exception. Array list. We also have to create that exception class as well. Then we'll say result points to list of index. Rear minus minus. Should be a space there. Well, if we use brackets, we don't really need one. This one doesn't use brackets, so then we'll say shift the elements. Or in scan equals to index, scan is less than rear, scan plus plus. list of index scan points to list of scan plus 1. So again, it's going to shift the elements the same way as we just did above. So it's going to shift, it's basically going to take the list of array index 0 and put in the list of index 1 in it, so all the elements will get shifted over by 1 to the left, where left is 0 and right is, for example, 5. So it'll shift them all by 1. And one of the elements will get dropped. Then we'll say list of rear points to null. And we'll say mod count plus plus. Return result. So here we'll do first, so it's like peak, first and last. First, we use it in queues too. It just returns the first element, the head element, the front element, whatever. So it returns a reference to the element at the front of this list. The element is not removed from the list, just returned. Throws an empty collection exception. Whoops. Okay, that throws an empty collection exception if the list is empty. At return, a reference to the front of the list, or the reference to the first element in the list. Reference to the first element in the list or the front of the list, doesn't matter. Then throws empty collection exception if the list is empty. I mean, you don't have to throw an exception again. I mentioned this before, but you can just system.out that it was empty, and then you can return null if you want the flow of execution to be that way, to not get interrupted. So it's up to you. So public T first throws empty collection exception. If is empty. So if the list is empty, throw new empty collection exception. Whoops. We'll pass in Arraylist. And then we'll return list of index 0. I guess we don't really need a head if we have index 0. So rear is really just like a top. It's the next available index and the number of elements in the list, I believe. We'll double check that. But I find it weird why we're setting it to null, so we can also debug and see why that's happening. Because I feel like the list, if we're removing from the front, then I maybe would have changed this. I would have just set that element itself to null. It's like T result points to list of 0. That's like a pointer basically. Then we could have, I guess it's really just shifting the elements over, so nothing's really getting set to null, but you could have specifically maybe set, you could have set T result points to list of 0, then maybe you could have set here, we could have set list of 0 points to null, like that. then we could have shifted the rear and then shifted all the elements over it, but then I guess it's the same thing and maybe it's unnecessary. Oh, where were we? Here. Say remove last or remove first? Like, there's always a few ways to do things. Some people might, like me for example, I might like to explicitly set it to null so I know that it's setting to null, not just being written over. So if we set it to null first and then shift it over, for me that would be better. But for others, it may not. And again here, it's like, well, you're setting rear to null. We could have just shifted it over as well. Like, we could have just went rear minus minus. That's okay, we'll just, we'll debug it. If we have problems, we can change it again. So we'll do last. So we'll say returns a reference to the element at the rear of this list. Just on that note again, you may not like how someone coded stuff. You may have your own way that you prefer to do. You don't like some of the things that they do. That probably will happen a lot, so you can always just change it. So here returns a reference to the element at the rear of this list. And then we'll say that element is not removed from the list. Throws an empty collection exception if the list is empty. Great, now it's out of the doc. So then we'll say at return a reference to the last element in the list or of this list. At throws empty collection exception if the list is empty. So returns type T, public T last, throws again empty collection exception. Set it like 3 times. And we'll say if is empty. Then we'll throw the exception. Pass in the string of the data structure type. Then we'll say return list of rear -1. Because rear is the next available element and the number of elements in the list, I believe. So if there's 5 elements, so if the index length is 5, and returning the last element, so 5, so length of 5, that means it's index 0 to 4. That means rear is probably going to be 5. So we'll return list of rear, which is 5 -1, which will give us the last element. That's why it does that. So the next one, we'll do contain, so returns true if this list contains the specified element. At param target, the target element. At return true if the target is in the list. False otherwise. Then public boolean contains, takes a parameter t target, Then we'll return the method find target. Did we do find yet? No, we didn't. We'll do it right below this one. Returns true if target does not equal not found. So returns true if the method find with the parameter target that we're looking for is not equal to -1. So here we'll do find. Returns the array index of the specified element, or the constant not found, or the constant not found. If it is not found. At param target the target element. At return the index of the target element, or the not found constant, which is -1. So private int find parameter t target. We'll set int scan to 0. Int scan equals to 0. Int result equals to not found. If is empty, which we haven't done yet. While result equals not found and scan is less than rear, then if target dot equals list of array index scan, result points to scan. So it's a little confusing, but we'll do it in the debugger. That's how we'll go through it. We'll have to work through if, then we'll have to do the loop. This is going to be the whole loop here, pretty much, because these are connected. That's why the debugger always will help you if you're not sure. Stepping through the debugger. Then here we'll return result. Again, that's why I don't like coding like this. I like coding with brackets to space everything out, so I don't have to say, oh well, is this part of the while or is it not? That way you won't know and you'll have to go through the debugger to check if it's someone else's code and you're not sure. But maybe they find that easier, but for me I don't, because it's not specific, because this is all connected. For me, I'd rather put like a bracket here. Whoops. I'd rather put a bracket here and a bracket here, something like that, so I know. So just a few more. We won't be debugging anything right now. Let's take a sip of some water here. Excuse me. You should do the same if you're following this long video. An even longer video series is probably going to be like 30 hours to go through this, or even more. Upwards of 40 hours. If each video is at least an hour, they're doing 5 per section, then this will probably be like 30-40 hours. So the next one, some of them are even 2 hours. So the next one will say returns true if this list is empty and false otherwise. At return true if this list is empty, false otherwise. So public boolean is empty. Returns true if rear is equal to 0. That's just the way they did it. So returns true if rear is equal to 0. That's okay. I usually do less than or equal to, but that's fine. Both ways work. I do that just in case there's a discrepancy somewhere, you have a bug and it goes less than 0. Then you'll know it's empty if that happens. So returns true if rear is equal to 0. Then here we'll do size. What's happening there? Returns the number of elements currently in the list, or currently in this list. At return the number of elements in the list. Whoops. So public int size. Then we'll return rear. Yeah, this video alone is gonna be like probably 2 hours or more. Once I finish them, the rest of them, I'll have to compile it. So public int size returns rear. And then we might even debug it too, so it could be upwards of 2.5 hours. So here we'll do a toString. So we have public int size. What's with the... So yeah, so it's saying it's from list ADT. So public int size. Return rear. Then we have our toString here. So public, actually we'll do the doc. Returns a string representation of this list. At return the string representation of the list. Actually, we still have to do the iterator stuff, so I think this might even be 3 hours. So then we'll return the string representation of the list. And we'll say public string toString. Then string result points to empty quotes. For int scan equals to 0, scan is less than rear, scan plus plus, result points to result plus list of scan plus new line. Return result. So you could just change these to I for int I is equal to 0, I is less than rear, I plus plus. For me personally, that's easier. But doesn't matter. So we'll take a break and we'll actually, can we do these quickly? 550. I guess we could just finish these so I don't have to compile them. So under here we're going to have a private inner class. Actually no, we're going to have one more method first. So returns an iterator for the elements currently in this list. At return an iterator for the elements in this list. Elements in this list, in the list, or this, doesn't matter. So public iterator of generic type T iterator. So we'll return new Arraylist iterator. We're going to have to import something here. Alt Shift Enter to import something here. So it'll be iterator java.util, not the HTML one. We don't have an Arraylist iterator yet, so we'll do it right here. So it's going to be a private class. So a private inner class, so here we'll have Arraylist iterator, iterator over the elements of an array list. So an iterator iterates over elements of a collection or a data structure. So we'll say private class Arraylist iterator implements iterator of generic type T, open brackets. What's wrong with this? So it's telling us we have to implement the has next and next and stuff. So here we'll have int iterator mod count, int current, some doc here for the constructor, sets up this iterator using the specified mod count, at param mod count, the current modification count for the array list, then we'll say public array list iterator, so it's just a constructor. Iterator mod count points to mod count. Where is mod count? Okay, so mod count is the variable that we set above, I think. Do we have a mod count up here? Yeah, we did right here, so it's setting that one to that one. It's a little tricky, we don't really do that too often using an inner class. So taking this one, we could have used this as well. We could have just said like this dot mod count, which would point to this one, equals to the mod count above, but I guess they just did it that way. Then we'll just say current equals to 0. And oh, it's not like that. We could type like that, but don't really like to. So for has next, we'll say returns true if this iterator has at least one more element. To deliver in the iteration. Then we'll say at return true if this iterator has at least one more element to deliver. So has next, right? Returns true if it has something. deliver in the iteration. Returns true if this iterator has at least one more element to deliver in the iteration. Kind of want to put that down here. And we'll say here add throws again. We'll have to throw something else concurrent if the mod counts get out of sync, so concurrent modification exception. So remember, iterators throw concurrent modification exceptions. You have to remember that iterators throw concurrent modification exceptions. If the mod counts get out of sync, then the whole iterator is going to basically not work properly. So you have to make sure it's all in sync with the mod count above. This one is basically in sync with the one in here, I believe. That way it's going to work, and if it's not, then you'll get a concurrent modification exception. Or it'll just be wrong. So throws concurrent modification exception if the collection has changed while the iterator is in use. So that's another definition for it. So public boolean has next throws concurrent modification exception. Did I spell that wrong? Modification exception. Still wrong. Okay, what's happening here? What's with this? So concurrent modification exception. So it's telling us to import it as well. We'll have to import it to get rid of that error. Now you can see we have that as well. Java.util.concurrent modification exception. You have to import it, I guess, or you could just import all of Java util. So it has next just does this. So if iterator mod count does not equal to mod count, then it's going to throw the exception. Then else, so returns true if current is less than rear. What's current again? Okay, so the current is just our current iteration, I think. So 2 more here. So for the next method, returns the next element in the iteration. If there are no more elements in this iteration, no such element exception. We also have to write that one too. Is thrown. Greatest now it's out of the doc. Return the next element in the iteration. Throws no such element exception. Throws no such element exception if an element is not found. Whoops. Throws If there are no more elements in this iteration and no such element exception is thrown. So they just did it this way, so throws a no such element exception if an element not found exception. They should have done it like this. If an element not found exception occurs, so it's kind of like setting pointers for exceptions, so then throws concurrent modification. Modification exception if the collection has changed. So public T next throws concurrent modification. Open brackets down here. If does not have next, throw new no such element exception. Is that a built-in one? I guess so, because we didn't do it. Okay, it is a built-in one. Or maybe it's not. Throw no such element exception. Okay, it's not. It is? Maybe it is. Okay, it is, so we just have to do the element not found exception. I thought there was one more too that we haven't done. I think there's 3 of them in this one. So then we'll say current plus plus, or plus 1. Then return list of current minus 1. So it's just shifting stuff around. So that we'll do the next one for remove. It's kind of stupid. It just says the remove operation is not supported in this collection. You might have to know this, so we'll just do this too. So throws unsupported operation exception. Yeah, you're gonna have to know these exceptions. So if the remove method is called, whoops, I wanted that to go through. So add throws, unsupported operation exception. If the remove method is called. IntelliJ took its redo button out for something else. I have no idea why they did that. I think it's like Control Y or something. Usually is, but they changed it. They set it to something else. It was pretty probably the stupidest thing they did. So throws unsupported operation exception. We'll say throw new unsupported operation exception. If we call the remove, then it's just going to throw the unsupported operation exception. That's all it's doing. So we'll take a break and we'll come back.